Mann whitney test is non-parametric alternative test to the independent sample t-test. It is a non-parametric test that is used to compare two samples means that come from the same population and used to test whether the two sample means are equal or not. Usually, the Mann whitney test is used when the data is ordinal or when its assumption of the t-test are not met. Mann whitney test, it was originally proposed by Frank Wilson in 1945 for equal sample sizes. Frank Wilson was a chemist and statistician known for the development of several statistical tests. Frank Wilson was born in American parents on September 2, 1992, and died on November 18, 1965. Mann whitney test is a non-parametric test, so it does not assume that any assumptions related to the distributions of scores. There are, however, some assumptions that are assumed. Number 1. The sample drawn from the population is random. Number 2. Independence within the samples and mutual independence is assumed. That means that an observation is one of the group or the other group. Number 3. Ordinal measurement scale is assumed. This is the calculation of Mann whitney test. U is for the Mann whitney test. In 1 is for the sample size 1. In 2 is for the sample size 2. R is for the rank of the sample size. Mann whitney test is used for every field but is frequently used in psychology, healthcare, nursing, businesses, and other disciplines. For example, in psychology, it is used to compare the attitude or the behavior and etc. In medicine, it is used to know the effect of two medicines and whether they are not equal or not. It is also used to know whether or not particular medicines cures the ailment or not. In businesses, can be used to know the preferences of different people, and it can be used to say if this is changes depending on location. Now let's apply Mann whitney test in problem solving. The Mann whitney test checks whether there is a difference between the two independent groups. The Mann whitney test, it is the non-parametric counterpart to the t-test for independent samples. As we can see in the picture below, it is the samples of independent sample checks, the t-test and Mann whitney test. In t-test, we will define is there a difference in mean of the two groups, while the Mann whitney test is there a difference in the rank sum of these two groups. In t-test, we will add the result of every members of the group and then divide in the two, and that is the mean of the groups. While in Mann whitney test, we will add and find the rank of every members of the group, and then that is the mean of the groups. And now we can see the data does not have been normally distributed. How do my variables need to be scaled? So we used a nominal or ordinal variable with two expressions. For example, in gender, there is one group of male and the other group of female. In medication, how do we find in drugs? So there is one who will find the drugs and the other one who will find the placebo. In production facilities, it is two groups, with this group A and the group B. And that is the example of independent variable. And the other side gives the example of dependent variable, a metric or the ordinal variable, which is the salary, well-being, and weight. The assumption of Mann whitney test have two independent random samples with at least ordinary scaled characteristic must be available. The variables do not have to fulfill a distribution curve. In null hypothesis, in the population, the sum of the rankings in two groups does not differ, while in alternative hypothesis, in the population, the sum of two rankings differs in the two groups. Example of problem solving. You measure the reaction time of small group of men and women and want to know if there is a difference of it. As you can see below, there is a group of female and male who tallied their reaction time, but the data are not normally distributed. Now we will apply Mann-Whitney test to rank the participants who tallied their reaction time. As I said a while ago, the null hypothesis, both rank sums are the same. Now we will calculate the rank sum of two groups, which is T1 is the group of female and T2 is the group of male. In T1, have the rank number 2 plus rank number 4 plus rank number 7 plus rank number 9 plus rank number 10 plus rank number 5. It is the sum of 37. In T2, rank number 11, rank number 1 plus rank number 3 plus rank number 6 plus rank number 8. It is equals the sums of 29. In solution, the number cases of female have 6 and the rank sum is 37. U equals to N1 times N2. We know that U stands for Mann-Whitney test and N1 for the group 1 and N2 is the group 2. Plus N1 times N1 plus 1 divide 2 minus T1. In group 1, have the 6 member. In the group 2, have the 5 members. So 6 times 5 plus 6 times 6 plus 1 divide 2 minus 37. The result is 14. In male, the number cases have 5 and the rank sum is 29. U equals to N1 times N2 plus N2 times N2 plus 1 divide 2 minus T2. 6 times 5 plus 5 times 5 plus 1 divide 2 minus 29. It is equals to 16. The 16 is the mean of the male and the 14 is the mean of the female. Now we will calculate the Mann-Whitney test mean in U1 and U2. The mean of U1 is 14, the mean of U2 is 16. And then the smallest number is 14 and that is the mean of Mann-Whitney test. And then we will calculate the expected value of Mann-Whitney test. So N1 times N2 divide 2, 6 times 5 divide 2, it is equals to 15. And that is the expected value of U. And now we will calculate the standard error of U. The square root of N1 times N2 times N1 plus N2 plus 1 divide 12, or square root of 6 times 5 times 6 plus 5 plus 1 divide 12. It is equals to 5.4772. For Z value, Z equals to mean minus expected value divide standard error equals to 14 minus 15 divide 5.4772 equals to 0.1825. And that is how we used for calculation of Mann-Whitney test in different variables of different two groups. Thank you for listening.